So some of you have been worrying, why do we even calculate the oxidation numbers of elements in compounds, in ions? Yes, it's for a reason. But before I talk about that, let's just recap. Remember those fundamental definitions of oxidation and reduction. One was saying oxidation is the addition of oxygen. The second one was saying it is the removal of hydrogen. The third one was saying it is again a loss of electrons, Then the fourth was saying an increase in oxidation numbers. So we have those four definitions. And for reduction, the opposite is true. That means reduction can be defined as the loss of oxygen, or the gain of hydrogen, or the gain of electrons. Lastly, the decrease in oxidation number. So once we have the oxidation numbers, sometimes we use them to specify which compound we are talking about. So to avoid any confusion when an element can have several oxidation numbers, the oxidation number is usually mentioned in the compound's name. For example, if we have got element X, so element at X, the number refers to the element, the oxidation of the elements, not the associated oxygen. I know when I say this, it doesn't make any sense. But let's just look at a typical example then. So, for example, we've got that potassium manganate 7. So what is that 7 for? It is for manganese. Manganate says the manganese is bonded to oxygen. So the anion actually has oxygen. So an anion or negatively charged ion with an oxygen, normally it ends with an ATE. We have manganate 7. Manganese has an oxidation state of +7. The chlorate 5. So what's the chlorate for? The chloro, that's chlorine. So in this case, chlorine has an oxidation state of +5. ATE, remember I said that's anion with oxygen. So we have chlorate 5 to indicate that oxidation state of chlorine is +5. Phosphorus 5 oxidifluoride. The 5, notice where it is replaced. It's after the element. Phosphorus 5, which means the phosphorus has got a +5. Sodium dihydrogen phosphate 3. Phosphate. We have an anion there with an oxygen, isn't it? The 3 is indicating that the phosphorus has a +3 oxidation state. Potassium dichromate. The chromate part, chromate 6. 6 is indicating the oxidation state of chromium, which is +6. So some of these compounds, we specify the oxidation state because there are more than one possible oxidation states of that element. So the oxidation state is to be specified. Thanks for watching. It's the Apex Chemist, Papanya Kungu. You find me at tinyakungu@gmail.com if you have any inquiries. Thank you.